I have e of x over g of x, and the degree of p of x is 1 degree higher than g of x, then that means you're going to have a slant asymptote, also known as an oblique asymptote. So for example, let's say I have x squared plus 2x plus 1 over x minus 3. Because the degree of the numerator is just 1 degree higher than the denominator, that means I'm going to have a slant asymptote. Okay, so let's go ahead and look at an example. Here's the first example. The numerator is 1 degree higher than the denominator, so that means we're going to have a slant asymptote. So I'm going to use synthetic division. So you can use synthetic division or long division to find the slant asymptote. Okay, so I'm going to use synthetic division here. 1, 0, -9. And what goes out here is you set the denominator equal to 0 and you solve it. Well, I just get x equals 0. You break down the first coefficient, then you multiply. 0 times 1 is 0, add 0. 0 times 0 is 0. You add and get -9. So the result is the equation x plus 0. This is just my remainder, so that is not important. So this is my slant asymptote. It's basically y equals x. So that is my slant asymptote. Now, you can watch the last lesson to know that the x-intercepts are 3, 0 and -3, 0. Your y-intercept is none, because if you plug in zeros everywhere, first you need to factor this. So if I factor the numerator, it will look like this. You set the numerators equal to 0. That's how you get the x-intercepts. Then you plug in zeros everywhere to get the y-intercepts. Well, you cannot have 0 in the denominator. That's why I said there is no x-intercepts. Your vertical asymptote is x equals 0. You just set the denominator equal to 0. There is no horizontal asymptote. Instead, I have a slant asymptote. Remember, if it's bigger on top, if the degree is big on top, that means you have no horizontal asymptote. Okay, so this is all the information. Nothing canceled out when I factored, so there are no holes. Okay, so I'm going to plot everything. I have my x-intercepts at -3, 0, and 3, 0. My vertical asymptote is at 0. Okay. My vertical asymptote is at x equals 0. My slant asymptote is at y equals 0. That's at the origin, and then you go up 1 over 1. So this is my slant asymptote. So that means my graph will look like this. Go close to the asymptote, go through this point, go close to the asymptote, go close to the asymptote, go through this point. It'll be a smooth line. So that is what my graph will look like. Because I'm going forever down, my range is all real numbers, and x cannot be the vertical asymptote, which is right here. So x can't be 0. Let's do another example. We'll do f of x equals 3x squared minus 7x over x minus 3. So in these problems, you always want to factor. So I'm going to pull out an x. Nothing will cancel out, so that means there are no holes. Your horizontal asymptote, well, it's big on top, so that means there's none. Vertical asymptote, you set the bottom equal to 0, you'll get 3. X-intercepts, you set the top equal to 0. You'll get 0 for one of them, and the other one will be 7/3. Y-intercepts, plug in zeros to find the y-intercepts. So I'll get 0 times 3 times 0 minus 7 over -3 if I plug in a 0 right there. Well, 0 times anything is just 0. So 0 over -3 is just 0. So your y-intercept is at 0, 0. Okay, finally, this is what's new. Okay, all of this stuff we learned last lesson. Okay, we already know how to do that. Today, what's new is the slant asymptote. So I'm going to go ahead and use synthetic division again. The coefficients are 3, -7, and I'm missing my constant term. Normally you have a plus something or minus something. I'm missing that. So I'm going to put a 0 since I'm missing it. And out here will be 3. Where did I get this 3 from? You set the denominator equal to 0 and you solve. So you get x is 3. That's what goes right here. The first number comes down. We're going to multiply. 3 times 3 is 9. Then you add and get 2. Then you multiply and get 6. Then you add and get 6. This number is not important. That is the remainder. What is important is this. It'll be 3x plus 2. That is the equation of the slant asymptote. It will always be linear. Okay, so that's what I'm going to plug in for slant asymptote. So my slant asymptote is at 3x plus 2. I'll go ahead and graph it. So for my slant, I'm going to start at 2, and my slope is 3. So I'll go up 3 over 1, like this. My vertical asymptote is at 3, right here. And my y-intercept is right here. X-intercept and y-intercept. And then this is about between 2 and 3, so right here. So I get close to the asymptote, go through my points. I'll also have one up here. So guys, if I were to zoom out of this graph, this slant asymptote would continue its pattern, and so would this vertical asymptote. And my graph would be right in between them. So if I were to zoom out, it looks like this. One up here, one up here, and one down there. And this was your vertical asymptote and your slant asymptote. This example, you always want to start by factoring. And this is supposed to say -6. Okay, so if I factor this, I'll have x minus 7 and x plus 1 over x plus 5. Nothing cancels out, so there are no holes in this example. All right, so if I set the numerator equal to 0 to find the x-intercepts, I'll get -1, 0, and 7, 0. For y-intercepts, you plug in zeros everywhere. So this becomes -7 times 1 over 5, which is -7/5. So that is my y-intercept. Vertical asymptote is -5. You just set the bottom equal to 0 to get vertical asymptotes. Horizontal asymptotes, it's big on top. So there is none. There are none. Slant asymptote, that's what we learned today. So I have 1, -6, and -7. -5 goes out here. Bring this down, -5, -11, 55. And this part doesn't matter because this will just be your remainder. I don't need that part. You just need this part. So this is your equation. Your slant asymptote is x minus 11. So I'm going to go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right here. Now, I know that some of you guys' paper just goes like to here. So if you were to graph this, it'd be off of the page. Well, that's no problem. No problem. What you could do is plug in numbers. So for example, if this is my equation, plug in a 5. 5 minus 11 is negative 6. So go over to 5, 1, 2, 3, 4, 5, and then go down 6, 1, 2, 3, 4, 5, 6. This is a point on your line. You could plug in a 6 next time. 6 minus 11 is negative 5. So go to 6, 1, 2, 3, 4, 5, 6, and then go down 5, 1, 2, 3, 4, 5. Boom, that's another place on your line. Once you have a point, you can just go up 1 over 1 because your slope is just x. Your slope is 1. So this is my line. So if you can't graph the y-intercept because it would go off of your page, just plug in a point and then use your slope of 1 over 1. There we go. So that's my slant asymptote. Let me graph other things. Erase all these dashes. Okay, next. My vertical asymptote is at negative 5. 1, 2, 3, 4, 5. Right here at negative 5 is my vertical asymptote. These will eventually intersect. Okay, and then I have a point at 0, negative 7/5. That's about right here. Negative 1, 0, and 7, 0. 1, 2, 3, 4, 5, 6, 7, right here. So my graph will be close to the asymptote, go through my point, like that. And your other one will be down here. Just can't really see it. Down there. If you were to zoom out, this is your vertical asymptote, this is your horizontal asymptote. Your graph would be here and here, if I were to zoom out. Next one, you always want to factor first. So if you factor the numerator, you will get 2x plus 5 times 3x minus 2. If you set the top equal to 0, that's how you find the x-intercepts. Top equals 0. So I'll have 2x plus 5 equal to 0, and this one, 3x minus 2 equal to 0. And then you just solve. So subtract 5, you get 2x equals negative 5, then divide by 2. So this is one of them. And then add 2, divide by 3, divide by 3. This is the other one. So your x-intercepts are negative 5/2 and 2/3. To find the y-intercept, you plug in zeros. So put a 0 here, here, and here. I'm left with 5 times negative 2 times negative 1, or divided by negative 1. 5 times negative 2 is negative 10, divided by negative 1 is a positive 10. So that's my y-intercept, 0, 10. Vertical asymptote, you set the bottom equal to 0. So this is the bottom, 2x minus 1, set it equal to 0 and solve. Add 1, you get 2x equals 1, divide by 2. This is your vertical asymptote, x equals 1/2. I'm going to go ahead and plot those things on my graph. So I have a y-intercept at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right here. X-intercept at negative 5/2, that's right here. 2/3 is like 0.67. I'll put it right there. And vertical asymptote at 1/2. Remember, this is approximately 0.67, and this is equal to 0.5. Okay, so this x-intercept is to the right of that vertical asymptote. Okay, now horizontal asymptote, It's big on top, so that's none, but we will have a slant asymptote. Now notice, this is not a 1 like the previous examples. The previous one, I have a 1. Previous one, it's a 1. Previous one, it's a 1. Whenever it's a 1, you can do synthetic division, but I can't do synthetic division here. I'm going to have to do long division. So let's do that. Whoops. Did it upside down. Long division, I'm going to do 6x squared plus 11x minus 10 divided by 2x minus 1. 2 times what will give you 6? That's 3. X times what will give you x squared? Another x. Okay, now we're going to multiply. 2x times 3x is 6x squared. Negative 1 times 3 is negative 3x. After this step, you are going to change the signs. That cancels. 11 plus 3 is 14x. You're going to bring down the next item. Next, 2 times what will give you 14? Or 2x times what will give you 14x? The answer is 7. You can just stop there because that's your answer. Y equals 3x plus 7. So I'm going to graph that up 7. 1, 2, 3, 4, 5, 6, 7 right here. And your slope is 3. So up 1 over 3. I can also go this way. Okay, so this is your slant asymptote. Okay, so this is your graph. Your graph will go close to the asymptote, go through this point, your y-intercept, go through the x-intercept, and then go along the asymptote, cross that x-intercept. There you go. That's what your graph would look like. So x cannot be that vertical asymptote, which is at 1/2, and your range is all real numbers. It just goes forever down, forever up, forever down, forever up. 7 ways to factor. This will be x plus 3 and x minus 3. Okay, x-intercepts. You set the top equal to 0. So you'll get negative 3 and you'll get 3. Y-intercepts, if I put zeros everywhere, this will be 3 times a negative 3 over 2, which is negative 9 halves. So that's 0 and negative 9 halves. Your vertical asymptote, you set the bottom equal to 0. If you solve it, you get negative 2. This is big on top, so this is none. However, we do have a slant asymptote, and the coefficient is 1, so I can do synthetic division. It'll be 1, 0, negative 9. On the outside will be negative 2. How did we get negative 2? You set this equal to 0, and you solve it. You get x is negative 2. That's what goes out here. Bring down the 1, negative 2, add, negative 2, multiply, you get 4. This part doesn't really matter because that's your remainder. We don't need that. This is your answer. So that's y equals x minus 2. So I'll go ahead and graph everything. You have your x-intercepts at negative 3 and 3. Y-intercept at negative 9 halves. That's 1, 2, 3, 4.5 right here. X, our vertical asymptote, x equals negative 2. That's right here. You have a slant asymptote right here, starting at negative 2, and your slope is 1. Let me do it in a different color. So your other asymptote is right here. This is your slant asymptote. Okay, so your graph is going to go through the points that we drew. So Go along the asymptote, go through the point you just drew. Along the asymptote, go through the points. And that's your graph. Your range is all real numbers. X cannot be that vertical asymptote, which is at -2. I'll do one last one. We have f of x equals x minus 6 over x squared minus 6x. Okay, so first I'm going to factor this. The numerator is already factored. The denominator, both can be divided by x. So if I simplify this, that cancels out. I'm left with 1 over x. All right, so this is my simplified function. X-intercepts, you set the top equal to 0. Well, 1 equals 0, that's not true, so there's none. Y-intercepts, you plug in zeros. Well, if I plug in a 0 here, you can't have 0 in the denominator. No zeros in the denominator. That's not allowed. So this is also none. Vertical asymptote. This means you set the bottom equal to 0. So if I set the bottom, I'll write that down. Vertical asymptote, you equal the bottom to 0. So set the bottom equal to 0. You get x is 0. Okay, I can go ahead and graph that. Vertical asymptote is right there. Horizontal asymptote. It was big on bottom this time. So if it's big on bottom, it's y equals 0. So I have a horizontal asymptote right here. Slant asymptote. Well, you only have a slant asymptote when the top is bigger by 1. So there is no slant asymptote in this case. Let me highlight my asymptotes. There's a horizontal one right here because it was big on the bottom this time. And we found our vertical asymptote. All right. And holes, we do have a hole because we canceled out. So whatever we canceled out the x minus 6, set that equal to 0 and solve. So I'm going to add 6, so x is 6. That is the x value of my hole. Now you plug this back into here, and you get 1 over 6. Okay, so I'm going to go ahead and graph my hole. 1, 2, 3, 4, 5, 6. 1/6 is like right here, very small. So this is my graph. Oh, you have a hole there. Let me write it as a hole and not a point. We fix that, and I'll make it a hole. You have a hole right there. The location of that hole is 6/1/6. So your domain, x cannot be the vertical asymptote, which is at 0, or the x value of the hole. This is x, this is y. It can't be 6. The range, y, cannot be this horizontal asymptote at 0, or the y value of the hole, which is 1/6.